All right. Hello, everybody. Welcome to Mr. Cahill and Mr. Peterson's first lesson today, derivative graphs. So we'll be looking into graphs that show the first derivative of a function, and we'll be analyzing the increasing, decreasing, critical points, local max and min, absolute max and min, concavity, and points of inflection on that graph. This is Mr. Cahill. Mr. Peterson fortunately can't join us. He's out gambling. But let's get right into it. Okay, so it's important to know that most of these problems will be seen on a f prime graph, which is the first derivative of a function. A function is increasing when the f prime is greater than 0, and then a function is decreasing when the f prime is less than 0. So pretty much what this means is for a function to be greater than 0, it has to lie above the x-axis, which is positive, and we know that it is greater than 0 because all of the y values above the x-axis are positive and the x-axis is 0. And then for a function to be less than 0, it has to lie below the x-axis, and all of the functions that lie below this are negative or decreasing. So if we wanted to identify where this function was increasing, we would say from negative infinity to negative 3, from negative 1 to 2, and then from 3 to infinity, because all of these intervals lie above the x-axis. And then if we wanted to say where it was decreasing, we would say from negative 3 to negative 1, and then from 2 to 3, all because these lie below. Alright, so the next thing we'll be talking about is the local max and local min of a f prime graph. The local max is where a function goes positive to negative over the x-axis, and vice versa for the local min. So on our graph, we see that we have local maxes at negative 3 and 2, as well as local minimums at negative 1 and 3. So next we'll be talking about the absolute max and min of the function. These are super easy because you can easily identify them on the graph. The absolute max is always the highest point on the graph. It's just absolutely the tallest point on the graph, and then the absolute min is the opposite, where it's just the lowest point on your function. For our graph, we had a absolute max at 3, 3, and a absolute min at negative 2, negative. Next, we'll be looking at concavity. And so concavity says that when f double prime is greater than 0, it is concaved up. And when f double prime is less than 0, it is concave down. But since we're working with only the first prime graph, the way we look at it is we look at the actual rise over run slopes of each of the parts of the graph. So instead of looking at it in increasing and decreasing or top and bottom, we truly look at where the function is decreasing. So it's dipping down here, rising, dipping, rising. So here at this point, it's going to be concaved down, and then we'll have it coming back up. So concave up, concave down, and then coming back up here at. So if we wanted to label where this graph was concaved up, we would go from negative 2, so negative 2 to 1, because we see it rising all the way to 1, so to 1, union. And then we also see this concaved up from 3 up to negative infinity. So we'll go 3 to infinity. Did I say negative infinity? I'm sorry. All right, so then if we wanted to label where our graph is concave down, we would say from negative infinity to negative 2, because we see that it is concave down to 2. And then from 1 to 3, because it is also, again, dipping down again to 3. So our last piece of this puzzle, points of inflection. This is where the x changes signs. We know that an x changes signs again, where we put our plus on the top, minus on the bottom, because all these values are positive, all these are negative. And we know when they change signs because it crosses the x-axis. So we see our function crossing the x-axis at -3, -1, 2, and 3. All of these points will be points of inflection because they are all changing their signs. Alright, so time to put that knowledge to the test. So this is a practice release AP exam FRQ graph. This is what they used. I want you to find the increasing, decreasing, local max and min, absolute max and min, where it's concaved up, where it's concave down, and the points of reflection. So go ahead and pause the video and find those. Alright, hopefully you had a chance to solve those. So here we go, I'll work it out. So our function is increasing from -3 to about -2, because this is where it crosses the x-axis to go negative, and we know this because it is positive. Our function is decreasing from -2 to 1, union from 1 to 4. And this is because all of this falls underneath of the x-axis and it is all decreasing. So our local max is going to be -2 and 1. This is because this is where our function goes from positive down to negative. And then also we'll count this. So this is a special situation here. So since this grazes the top, it goes straight at 0. It doesn't technically change, like fully go into the top, but since it goes to 0, it is a sign change, so we'll call it going to positive. So since it goes to 0 and goes back down, this is also a local maximum. So our local maximum was -2 and 1, and then our local minimum is going to be 1 and 4. And this is for the same reason, because the x is going from negative to positive. Although it's not fully over the x-axis, it is still grazing it, which means it is 0, which means it's losing its negative. Our function's absolute max is -3, 3. And then our absolute min is -1, 2. -2. This is because this is the highest point on our graph and this is the lowest point, and we know that we are allowed to use endpoints on absolute maxes and mins. So we see that our graph is concaved up from -1 to 1, and also from 2 to 4, because we see their slopes or their second derivative are going up. And then our graph is concave down from -3 to -1. So -3, -1, you see it's going down. And from 1 to 2. And then lastly, our points of inflection are going to be -2. So -2, 1, and 4. So remember to count all these, even though they're not going fully through the x-axis, they're still grazing it, which counts as changing signs and point of inflection. So that concludes our video. Thank you for watching. Hopefully, watch it over again if you need some extra help, but hopefully that got you that A. Have a good one. Why you keep that tool like that? Why you